Okay, welcome everybody. My name is Lauren Shores, and I am the lead for mentorship and networking at Black Tides Data. I'm also our data science director. And today I want to walk everybody through a project, a personal project that I worked on, having to do with understanding education attainment in Chicago public schools using Python for analysis and regression. Now, I'm just going to give a disclaimer. I'm not a CPS expert. I don't work in Chicago public schools, so nothing you hear in this session is going to be an assertion of my expertise about CPS. The point of this talk really is to show you how you can harness data to dig into questions you might have, how to solve problems, and how to think about them using data. So that is what we will do today. Thank you for coming. So, like I said before, this project is digging into understanding why some schools in the Chicago public school system perform better as far as student results and outcomes. Um, in this project, I am going to be using data published by Chicago Public Schools. They do a progress report every year. So I'll be using their progress report from the school year ending in 2018. And I will be melding that data with some census block group level data that contains demographic information. And the two main things that I'll be wanting to answer or get insights into are what factors influence educational academic attainment in the schools, and also if neighborhoods factor into that performance. So if what neighborhood the school is in um, has anything to do with how those schools perform. Now, this is a talk about, CPS and data harnessing Python. I do have some slides here that basically will walk us through the whole process. That's what my agenda is, the life cycle of a data science project. But I want to get a show of hands of how many of you guys actually want to see code uh, because, if you do, then we can also jump over to the Jupyter notebook. Okay, I got a hand from Natasha. Cool. Okay. Um, yep. Okay, cool. Folks want to see code. That's fine. So I think what I'll do is I will walk through the slides, which will give you an idea, like I said, of the project life cycle, the thought process, and how I approach the data. And then we can jump over to the Jupyter notebooks so you can actually see what some of the code looks like. So yeah, the agenda, like I said, is the life cycle. I'll tell you kind of my approach, the data, the EDA, the modeling, and then the results. So let's get started. As I said before, the data that I'm using for this project is data published by CPS on chicago.gov. It's their progress report. And this data contains metrics, um, a lot of different types of metrics. They have scores on reading and math attainment, the growth of those scores, student attendance, behavior, surveys about engagement for both teachers and parents, health information, creativity metrics for the schools. It has all types of things. And the 2018 report had 654 schools in total. And these schools did include latitude, longitude information, meaning, they were right for us to be able to, like I said, map them to some geospatial information as well. Um, And also, it's worth noting, obviously, there's, different grade levels. Different schools going to have different things. So there were elementary, middle school, and high schools included in this data set. The majority of the schools were elementary schools, with 400 of them, 470 being elementary. And so, you know, just my thought process with addressing this question. First, we're talking about education attainment. What does that even mean? So as I'm going through and looking through the data set, I'm trying to understand or think about what in this data would be a good marker of educational attainment. And, if we are dealing with elementary schools and high schools, all features aren't going to be available for every school. So let's say we have reading attainment scores for testing for grades 2 through 8. Obviously, high schools are not going to have that information. So right away, I was forced to make some decisions about what types of schools that I wanted to focus in on, as far as digging into this question. And ultimately, I chose to focus in on elementary schools because they have the more data. And since part of this is to do a bit of modeling and regression, the more data you have, the more statistically sound whatever you see is going to be. So off of jump, I chose to focus in on elementary schools. And then also, what metric, as I'm going along, looking at all these things, what things are going to signal education attainment. I chose 8th grade reading attainment. So this was a numerical value for each school, basically a number between 0 and 1. And that number is basically like a percentile, like, oh, this school's reading scores is in the 80th percentile or something like that. And I chose reading because, reading is fundamental. I felt like it's a good marker of, how prepared you are to continue education. And I chose 8th grade because obviously this is the stepping stone to going off to high school and hopefully eventually college. And so, yeah, I just thought 8th grade reading scores would be a good marker. So that will be our target variable, just to be aware of that. The other data set I talked about that I would be using was the census block group level details, which I got from the American Community Survey. I believe I have links to all of this stuff in the Jupyter Notebook, which I'll definitely share. It's on GitHub. And so this data set had details like median household income and racial composition for these different census block groups. All right, so again, we're looking at the data, we're putting our data science hats on. So some things right away, before I even dug too deep into the data, to just be aware of was, after I chose my target, 8th grade reading attainment, that left me with just 418 schools or rows. So the data are small. And then also a lot of the features in the data set were autocorrelated, which just means that they're related to each other. They have some type of connection. So just being mindful of possible relationships between variables and how that may influence outcomes, especially when modeling. And then I wanted to note that I am using this census data, and I'm doing that by tying where the schools physically are to a census block group. But I wanted to just be aware that this may not be indicative of the school's actual composition. Now, we are pretty aware with schools. Some school systems, you have to go to the school that's nearest to you. It's a zoned neighborhood school, where there are other schools that maybe you have to test in to get into, or some other criteria to get into the school, not necessarily that it's in your neighborhood. So just keeping that in mind, that a school might not necessarily have the same demographic makeup as a census block group, based on the fact of what kind of school it is. So data cleaning, that's always a very important part of digging into the data. Of course, there were some missing values. I imputed some values, got rid of some variables when they didn't seem like they would be too important. So that's an important step. And then obviously, schools that didn't contain the target variable weren't going to be useful for this analysis. Feature engineering. So again, talking about data, obviously, feature engineering is kind of an iterative thing. So you may have some ideas offhand of some features that may be helpful based off of what you already have. Or you may come to think of more as you dig into the data. Some things that I did was turn some of my demographic variables that were like percentages. Let's say this census block group has a Black population of 60%, converting those percentages into a categorical representation. So saying this block group falls into a low population, Black population, a high population, a middle population, rather than using actual percentages. And then I also created some variables that reflected the difference between a school's metric score and the average. So just kind of focusing more on how far away from the baseline that school is, rather than the overall metric. Okay, let's go to the next. All right, so for this EDA, I have several EDA slides. I know we'll jump over to the code, but I'll just say a couple things about EDA. First of all, just kind of where my thought process is when I'm about to dig into some data. I usually like to, of course, do the info thing with your data set, with your data frame, and just kind of get an idea of the distribution, the minimum, the maximum of each feature. Well, this will only work for numerical features, obviously. How many missing rows there are for that feature, the average, things of that nature. I also like to do a pair plot, so I can see pairs of features plotted against each other. That helps to kind of see what the relationships are amongst the variables. And I also like to do like a heat map, like a correlation heat map. It's a very similar thing, but you're actually getting numbers, correlation numbers that are easier to see. And then I like to do a lot of distribution plots. So in this slide, we have box plots. I do a lot of box plots, histograms, things of that nature, to just kind of dig into my variables a little more. And then for categorical variables, looking at how much of the data falls into each bucket. And again, I can show you guys that when we jump over to the Jupyter notebook. But that's just an idea of kind of the techniques that I like to dig into when doing an EDA. Here, I'm gonna just walk you through some of the things that I saw when I used some of these techniques. So first off, 8th grade reading attainment is higher on average than reading attainment for the lower grades. and it has a smaller range of variability. So I thought this was an important point because, it could be saying that, um, you know, maybe kids are learning something, like you're closing the gap as you get more and more through school. Um, Another thing that I thought, which may be less encouraging, is that um, kids don't make it to the eighth grade. They get held back. And so the kids that do make it to the eighth grade are the ones who are, better at school. And so that's why it looks like the gap is closing as you get from grades, say, 2 to 8. So that was just an interesting thing. Correlation between second grade and eighth grade reading attainment is only 0.65, whereas correlation between eighth grade and math and reading is 0.85. So higher correlation for scoring on two different tests of the same grade. This may support kind of the point that I made above. It could just be, eighth grade, you're talking about the same kids, so you don't have to like extrapolate some meaning to performance. It's these kids are performing in this way because they're in the same grade versus second graders and eighth graders. Um, so neighborhood schools make up 74% of the schools and have a wide range in reading attainment. So your neighborhood schools are going to be the schools that I kind of touched on earlier, the ones where kids go to these schools because that's where they're zoned to go. And if you look over at the box plot on the right, you can see neighborhood schools in the red. They have amongst the largest range from almost 0 to 100. Um, so they have like not the best performance. But surprisingly enough, the median performing schools in neighborhood schools are about the same as charter and small schools, which I thought was interesting. I don't know where everybody's from, but I know that oftentimes there's this discourse about charter schools being better and maybe a more effective way to organize education. But this is showing, the median is pretty much the same. And then even the 75 percentile of neighborhood schools perform a lot better than charter schools. So I just thought that was worth calling out. Yeah. Okay. Some other interesting things, digging into the data. So I mentioned that there were different surveys, metrics for surveys in the data set. One of them being quality of the facilities, and another being parent-teacher partnerships. Well, it was very weird that for both of these, you would think better quality facilities, better reading attainment, better partnerships, better reading attainments. But we see here the very weak schools for both of these actually have higher medians overall than all the other schools. Yeah, just perform higher overall. Don't know what that means, but again, I just thought it was worth calling out. Maybe, that's another question to dig into for another day. So this box plot is of the different neighborhoods in Chicago and their reading attainment scores. And I just sorted them, probably by the median. And you can see here that across all the different neighborhoods, there is a rising difference. If there were no neighborhood effects on school attainment, or if neighborhood didn't matter at all, I would assume that I'd see a box plot where mostly the medians aligned rather than having, upward or downward, depending on how you look at it, slope. So yeah, we just see that, what neighborhood you are in or the school is in does show some trend about how this school is going to perform. We even see like not only are these top performing schools with higher medians, um, they have higher medians, but they also have shorter ranges of scores, meaning kids are mostly around performing around the same area versus some of these wider ones. Even if the median is up here, you still have a wide range of performance. So thought that was interesting call out as well. And then I think this is our last EDA, so bear with me. I think this stuff is interesting, but these plots have to do with the census information. I mentioned before that I bucketed like demographic population, so white population, Black population. And this is just a quick look with those buckets to see reading attainment. And so we do see schools in census block groups with low levels of white population versus high. The schools with the higher white populations tend to have higher reading attainment. And unfortunately, the inverse is true for Black census block groups or schools in those census block groups. So, okay, let's talk about modeling. Um, so we got a lot of information now. We're kind of understanding, a little bit of some trends happening with CPS. And we ultimately, like I said, want to understand the relationship or what factors are factoring into educational attainment, specifically eighth grade reading attainment, because that is our target variable. In this analysis or this modeling exercise, I use the stats model package in Python because it actually gives good summary statistics about the model. And it allows a pathway to more easily understand if your assumptions of linear regression are being met. I know, if you've been out here interviewing or anything like that, looking at job descriptions, many will mention scikit-learn as something you need to know, and definitely you do. But that package is more centered around making predictions on new data, making data pipelines, training test sets, and things of that nature. So just to start, I use stats model because I really wanted to lean into the inference side of regression for this. And then, I started off with my ordinary least squares regression model. And then after I kind of was seeing the results and understanding like, okay, we got a lot of variables, there's a lot of collinearity. So a lot of the variables are related to each other. We need to get rid of them. I moved on to using lasso regression to kind of reduce the dimensionality of the data, and just to kind of understand what features are important, which is a big part of what we're trying to do here anyway. And then finally, I went ahead and used random forest to get a non-parametric understanding of the relationship between the variables and what the important variables are. Yeah, so let's look at the outputs for the models. So as I mentioned, I use these three: OLS, lasso, and random forest. For OLS, I came out with a pretty good R square, 0.7. In case you forgot or don't know, R square is how much variability is explained by your model. So this is good. However, and I don't have this in front of us because can't put it all on the slide, but looking at the outputs for this model, none of the features were statistically significant. And when I say that, we're talking about our p-values here. So, that's that's a red flag. Like, how good can we trust what's going on here with no significant features? So I moved on to Lasso. And our training, so for this, I went ahead and broke the data up. Moving forward in the other models, I'll break the data up into training and testing um, as a way to kind of use accuracy metrics to see how good the model is doing. And in so we have our R squared here for both the training and test set. The R squared is a little less for training, definitely a lot less for test. That's to be expected. But we have our root mean square error. So we have our error metrics here, which is 12. In case you don't know or forget, RMSE is an error metric that is in the units of whatever the variable is. And so we are talking about reading attainment score. Like I said, it's a number between a 0 and 100. So this is basically saying there's an error of 12 off of whatever prediction this model, like 12 units of, if you want to call that percentiles, that's the error for this lasso. And then the last model that I tried, again, random forest, I like to use because we're not bound by, like I said, the constraints of or assumptions of a linear model. And for here, I have the test R square, which is better than lasso. 26 is fine for a test set. And our root mean squared error is a little more than the training for lasso, but a little less than the test. So definitely a bit of a model improvement. And both the lasso regression and random forest allow you to kind of see what the important features are. And so here we have the top three features I've listed here, which is truancy, mobility, and demographics. Okay. Okay. I'm just gonna look over at my notes. Okay. Results and discussion. So truancy and mobility are important. Like these came out to be our important factors, and they seem like things that you could take action on. When we're talking about mobility rates, we're talking about how many students are transferring in and out of schools. And obviously truancy is if the kids even come to school, right? So theoretically, there are actions that could possibly be taken to address these things and maybe get better outcomes for these students, getting them in school, getting them stable, stable in school. Neighborhood disparities are real. So we saw the box plot with the different medians for reading attainment sloping up. Also, it wasn't shown in the slides, but the linear regression output for Lasso also listed some neighborhoods as statistically significant factors contributing to reading attainment. And some of the neighborhoods they mentioned were Austin and Inglewood. For those of you not from Chicago, these neighborhoods are on the south side. They are majority Black. And in our model, the coefficients for these features were negative, meaning, if you add that feature into the model, education, reading attainment is going to be lower. And then the last point of discussion is, again, just kind of these weird things we saw in the data, safety ratings, parental attainment, these things having unexpected relationships with reading attainment, whereas you would think safer schools with more involved parents would have higher reading scores, but this wasn't the case in the data. And then this, oops. Okay. All right, so this is just kind of running through, kind of driving home some of the things I've already mentioned. Truancy and student mobility were top predictors of lower reading attainment. These metrics alone displayed a lot of variation. Higher income, predominantly white neighborhoods tended to perform better. Schools in these neighborhoods tended to perform better. Debunking common assumptions, again, looking into those things that are kind of wonky as far as like safety and parent-teacher partnerships having inverse, counterintuitive relationships with attainment. And then things like charter schools not outperforming neighborhood schools. So this analysis is interesting because it's making us challenge some of the assumptions that, we have about these types of things. And the last point, narrowing performance gaps. Again, I hinted at this at the beginning, but like 8th grade reading scores being higher on average and showing less variability than lower reading scores. I think this is something that should be investigated. We want to know the reason why this is happening, because that could shed light on some things even more. So some of our opportunities, piggybacking off of what we're talking about, what we were just talking about, we need more data about the schools. If we had more information about class sizes through the different grade levels, we might be able to dig more into kind of that, even that last point about, our kids just not making it to 8th grade. And that's why the ones who are making it are scoring higher, or is there something else at play? To improve this analysis, we would definitely want more data over more school years. We could pull in more progress reports. The chicago.gov site does have many more years. I didn't pull them, but that is definitely an opportunity there to enhance this analysis. And you might get more solid model results. And then more solid connections between demographics and schools. Like I said, we use census block groups as a proxy for the school makeup, school demographic makeup, but it is just a proxy. And so it could be helpful to have that information directly from the schools. And then obviously any project will benefit from the domain knowledge of the people who work there. So that's definitely an opportunity for improvement. So that is the end of the slideshow. I am gonna stop there. I'm gonna give us a second to have questions, and then I'll hook it over to the Jupyter notebook because people want to see code. So do we have any questions about any of this?
So, Lauren, I have a question.
Mhm.
Can you talk a little bit more about how you chose the models that you use to evaluate your study, or do the evaluation for your study?
Yeah. So I like to start off simple. Um, Obviously, we know that I chose a target variable that is numeric, right? So that right there is going to influence what kind of model. Obviously, regression comes to mind. It's kind of the simplest model you can do, and if your assumptions are met, it's a good model because it's easy to understand. And since this project is all about understanding the relationships rather than just making a model that makes good predictions, um, I wanted to start there. Um, the lasso, as I said, is a form of regression, but it adds a penalty to the cost function. And so effectively, it kind of X's out non-important features uh, by shrinking their coefficients down. So again, this was a good next step model because we want to know what features are important. And Lasso would help us with some of that feature selection aspect. And then lastly, I did random forest because that's one of my go-to models. It's an ensemble. It's very powerful. Just leveraging different cuts of the data, and also you're not bound by those assumptions of linearity. So I like to use random forest when I can, and also it does have the aspect of giving you outputs for feature importance, which again was key to this analysis.
Thank you for sharing, Lauren. I just want to highlight that having, been in the field for a while, Lauren's point about simplicity is super important. I think these days people want to go to neural networks a lot, and those are great. But if you're dealing with a smaller sample size, I think the idea of simplicity is important. A lot of times people, again, want to go to the fancier models, not knowing that they aren't appropriate. And that's usually how I can tell I'm dealing with someone that doesn't know as much about data, right? If they say they want the shiny, bright thing, and again, neural networks are what a lot of people love, and those are great depending on the context of the story that you're telling. But I think, as Lauren highlighted so eloquently, simplicity is usually best. And, going to other types of modeling, backing up the choice of simplicity worked out really great. So thank you, Lauren, for that explanation.
Thanks for your question. CJ, I see your hand up.
Since you used two different models, would this be considered mixed method research?
Well, I'm not a researcher. However, I didn't use the models together. As I said, I know in industry, modeling is always an iterative process. So it's very rare that somebody will pick a model and just stick with it. Most of the time, you're going to try several different models. Um, Kim may have more insight to mixed
Yeah.
method.
So I wouldn't say this was a mixed methods only because typically with mixed methods, you're looking at both qualitative and quantitative. And I think that what Lauren mostly focused on here was quantitative. So for example, if she had included survey data from parents whose children are in public schools, right? That I think would make it fall under the category of mixed methods. With that said, I am a researcher, but I have not highly experienced in mixed methods. But from what I know about it, it was the approach that she took was appropriate because again, mixed methods would have involved qualitative and quantitative, and then she could have made it that way. Like again, including something like survey data would have been a good way to make it qualitative. But yeah, the focus for her study was mostly quantitative, and so not mixed methods in this case.
I thank you. This contact is helpful. I'm not a researcher either. I don't have a PhD or anything. So just the knowledge of industry versus research, that explanation was helpful. And then also, I'm not used to like using more than one model. So I didn't even know that that was like a normal thing in industry. So thank you.
You're welcome.
No, Lauren is, I guess y'all ain't saying the bomb anymore. Whatever y'all saying right now. That's what Lauren is. She's really excellent. But I'm gonna have to disagree with Lauren. She is a researcher. Sorry, Lauren. What you did was research, and I hope you plan on sharing it with Renee, by the way. This was an excellent demo of your skill set. That's off topic for the rest of y'all. She knows what I'm talking about. Anytime you do a study on something, you've read papers, you looked at published articles, that's what by definition is research. And you don't need a PhD to do research. I've been a researcher for 20 years and just finished my PhD in December. So with that said, y'all, think we got to think a little more positive about ourselves. We need to collect our flowers and roses and whatever else y'all collect and saying these days, right? Probably all of you here are researchers. The fact that you're interested in this subject tells me that there's some research, something going on there. So yeah, we all of that, researcher, data scientist, all the titles. That's what we are.
That is true. You're right, Kim. All right. Any other questions before I hop over? I know people wanted to see code. So any questions? Okay. I'm gonna hop over to the code. Is there anything in particular in the code you guys want to see? Because there's a lot of code. Luckily, I am a very organized person, so they are all sectioned off, and I can toggle through the sections. But is there any thing in particular that you want to look at? Maybe it's the EDA stuff, maybe it's the modeling stuff. CJ? Yeah.
Yes, so you talked about some like data transformation aspects, and I think one of them, I know I'm not using the right terminology, but you mentioned like features are interrelated, and that might influence the outcome. So I'm not sure if you like remove certain data points. I just wasn't familiar with what you meant by that.
Yes. So I mentioned, yeah, auto-correlated variables. I'll try to find it in the code, but basically I will go to I'm gonna go to the modeling outputs because I think that's where you can see better when you get a situation like I had for that first regression model where the R squared is pretty good. I think it was zero point 0.7, but the none of the features were statistically significant. That could be a sign that there's a lot of relation, or maybe there's too many variables in that model, and so none of them can shine properly. Um, and so in that case, you want to figure out how to get rid of some of those variables. And so that's kind of what I meant by that. And let me elementary school model. Okay, so this is the modeling section, first try model. All right, so this is good. This is let me shrink this so I can see. This is the output that I was telling you about if you use the stats method package. This is a typical regression summary. And you have your R squared here. Like I said, it was 0.7 for that model. You have your adjusted R square. It's much lower. That also could be an indicator of autocorrelation. So those interactions between those variables. And then I was talking about the statistical significance of all the variables. It's a lot of them. But all of them are, not all of them, but most of them. Mobility and truancy aren't, they stay true to being important. The standard, if you don't know, is having a p-value of less than or equal to 0.05. So if this number is less than or equal to 0.05, you can say, okay, it's statistically significant. It's just a standard that people use. There has been some controversy about it. Some people give it more weight than maybe it should have, but it's a good place to start. And as you can see, most of these variables are way above that. And so that prompted me to say, okay, we need to get rid of some of these features in this model. So that's what prompted the lasso. And basically, once you, I think for this, I'm pretty sure the way I did that was I did the lasso regression, and then I looked at what features were significant and then fed them back into a regression model. So manually putting in what features I wanted to continue on with the analysis. Does that make sense? Also, sorry.
Yes. Oh,
Yeah, yeah, go ahead.
I was gonna say yes, that makes so much sense. It all tied in together. Thank you so much.
And Lauren,
Yeah.
let me just add in a little bit here. So there's a couple things I think your study kind of highlights. And one of the things that, if any of you have been to the mentoring and networking events that I've participated in, you've heard me talk a lot about subject matter expertise. So one of the things that subject matter expertise gives you is an ability to know which variables you can screen in and out of a data set. And that's why I talk about it so very much, right?
Mhm.
So with that said, an analysis that may have proven helpful is logistic regression. And the reason is because, and I used it for my own dissertation, and the reason I say that is because one of the things logistic regression allows you to address are confounding variables. So variables that affect one another. So 2 points here. One is this emphasizes why subject matter expertise is so useful. Now, with that said, Lauren, she mentioned on the front end, she's not an educational data scientist yet. I qualify that and she knows why. And so she used lasso because she, wasn't an educational data scientist, wasn't sure what variables would be useful and what wouldn't be. And that was an excellent way of going about it when you're not familiar with the data set. However, it also makes the point of why subject matter expertise can be critically important. Because again, the only thing I would have done differently with this study is I would have added logistic regression, and then I would have looked, set up my analysis such that I could, analyze the variables which would confound each other or influence each other. That's kind of built into logistic regression. So maybe the next step for this study could be this research study, which could become a paper, Lauren, hint, hint, is to consider logistic regression, because then you're going to be able to address confounding variables. So just want to throw that in there. So again, logistic regression is just another machine learning technique. Again, I just did it for my dissertation, so I know a little bit about it, but there are definitely ways to statistically address any type of issues you can have with the data. But again, I'm going to harp on this point. It emphasizes, number one, why AI isn't going to take over anybody's job right now. It doesn't have subject matter expertise, but that's where you kind of can come in. So if you have that educational subject matter expertise, it would allow you to help pick your modeling. It'll help you with choosing which models would be better and which ones aren't. In the absence of that, do what Lauren did and use lasso. So just want to throw that out there. Subject matter expertise, guys.
Yeah. And just to piggyback off of what Kim said, I did mention that as an opportunity, having that domain expert. Data is powerful, but it's always even better when you have somebody who knows the context, Um, and CJ, that answered your question. Was there something else you wanted to see? Anybody else have anything else they want to see? I think we have 5 minutes. So I want you to get everything you can out of this.
Hey,
Okay.
Lauren.
Oh, all right.
Hey,
Yep.
yeah, I was wondering, can you go back to the code that you used for your feature engineering? Is that there?
Yes. Um,
Sorry, I had to run to find a conference room so I can speak. Um, yeah, all of this is so on time for me. So thank you so much for this session today.
Oh, thank you for joining.
Like I'm literally learning this stuff like in real time right now. So
Great. Okay. Okay, so this is kind of getting rid of data. Create any variables here. This guy, columns, control. Okay. So this isn't engineering per se, but this is kind of the start where I'm looking at the variables, looking at the numeric columns. I dropped any columns that were growth and not attainment. Just like I said, some of these columns had to do with high school metrics, so getting rid of those. There's a lot of methods in Python that you can use to do that. I don't know everybody's familiarity with Python, but this is list comprehension. It's basically a for loop, but in a more succinct manner format. So these list comprehensions are basically just looping through and getting rid of columns that meet certain criteria. These are kind of doing the same thing. Let's see. You know, the feature engineering. What's this? Okay, so this is feature engineering. This is some of the basic things that I did to make new features. So I mentioned metrics that were looking at the difference about the average. So for this example, we got school survey student and teacher response rates, right? Well, the actual variable is just the rates. What I did was I took the average of these rates and subtracted the school's individual score from them to get the difference. So we're actually seeing the variability of that school's score from what's normal. And this is just a simple example of feature engineering. And I did it for all of these diff variables are variables that I created with that same concept of mind of seeing how far this school is away from the average. Is that what you were looking for, Natasha?
yes, thank you.
Cool. Anybody else have any questions? While I'm waiting, I'm gonna remind everybody there's a survey in the chat. I just resent it. Please do fill it out. We love your feedback. We want to know, are these presentations hidden right? Is there something in particular you want to hear from us? All of that good stuff. So please do fill out the survey because it helps us to better serve you guys. Any other questions?
I have a question about Jupyter. It's random. I just know you're in Jupyter. I had downloaded it. Is it normal that it's able to open all the files on your computer? Like if you go to the kind of landing of where the files are, is your like complete computer documents up, or should it only have access to certain folders?
Jupyter will have, like, you mean this?
Yes.
Will have access to whatever folders you open Jupyter. So usually you open Jupyter from terminal, right? I don't know if you're on a Mac, but
On the Windows.
so I'm not, how do you open Jupyter? Do you do you go into like what's your terminal equivalent for Windows?
The command
I
line.
guess it's the
Yeah.
terminal. I don't want to get into troubleshooting. I'm
Okay.
sorry.
I'm just saying, well, basically, so the way I open Jupyter oh, you can't see when I change my screen, but if I go into terminal, the way I open a Jupyter notebook is in my terminal, whatever folder I'm in my file system, I'll type Jupyter notebook. And so Jupyter will only give access to files from that level and below that I opened from the terminal. So in this case, I opened Jupyter. I have a data science projects folder. I went to that folder in my terminal. I typed in Jupyter Notebook and it opened. So these are all the folders that I have in that data science notebook. And Jupyter right now doesn't have access to anything outside of that folder.
Okay. Mine's opens up in my browser, and when I open it up, it has access to my entire desktop, and that's why I asked. But I did used to have a Mac, and it used to be like that, how it only has access to certain folders. So I think I just did something different when I installed it on Windows. So thank you.
You're welcome. Sorry, I don't, I haven't used a Windows computer.
I usually use Jupyter Notebook through Conda on Windows and actually on Mac too, but so I don't know if that makes a difference.
Okay, thank you.
Know how it works on the back end. Now that I think about it, I'm like Lauren. Some depends. I mean, I may open it just by typing in Jupyter Notebook, like she said, but I usually go through Conda because I can use other programming languages when I do that, like R.
Okay,
Multitude of different ways to do it, I guess, is what we're getting at here.
Yeah.
thank you.
Okay, it looks like we are at time. So I want to, like I said, thank you all again for sharing your lunch times with us, and hopefully you got something out of it. And we hope to see you at other Black Ties Data events. So thanks, everybody.